So right now you can see our cell is an interphase where we just have our free-floating DNA that is not yet replicated, but during interphase, our DNA will get replicated. Okay, so after interphase, the DNA has been replicated, so we now have two chromatids that are together, and then we have our homologous chromosomes, which will find each other, and you have them right here. Okay, so here in metaphase 1, you'll have the homologous pairs will line up opposite from each other in the cell. This is for each other homologous pairs. Okay, so here now the cell is in anaphase 1, and the homologous pairs are going to start moving away from each other to opposite poles of the cell, just like that. Okay, so now here in telophase 1, you'll start seeing the differentiation of the two cells, and you'll see that each cell will start having one homologous pair in each from each set. Okay, so now here in cytokinesis, the cell will split, and you will have two chromosomes in each, one having a copy from the original cell. Okay, so now each cell now is in prophase 1, where you have the two homologous chromosomes again, just like that. Okay, so now in metaphase 2, I meant to say prophase 2 the last time, the chromosomes will line up in the equator of the cells again, just like this. Okay, so now here in anaphase 2, the sister chromatids will separate from each other, and they'll both start moving to opposite ends of the cell. And this, again, all these processes will be happening in both cells simultaneously, because they're going through the second phase of part of meiosis. So now here in telophase 2, those cells will be starting to split apart, and the DNA themselves will be moving more towards the end of the cells. So now here in cytokinesis 2, you'll see the two cells will now divide, and you'll have your 4 cells, which in this case are gametes, and they all are slightly different from each other due to the randomization of the different DNA and alleles that they have all received.